Okay, so we're stepping a little bit away from the nuances of set builder notation and getting a little bit more into linear equations and getting more familiar with them. So building on what we learned from Unit 3. And we're going to be talking again and revisiting what an intercept is. And if you remember that the value of an intercept, or what an intercept is, the value of a variable when the other variable in an equation equals 0, right? So if our values, if our accesses are labeled, you know, x and y, right? The x-intercept is whatever the value of x is when y is 0, okay? And the y-intercept is whatever the value of y is when x is 0, right? So that's one way to kind of look at it, right? So think about it that way. Okay, so here we have a line segment. We have a line segment here, and we need to find all the key segments of this line. Okay, so by the way, the lesson is identifying key features from lines and graphs. By the end of this, you should be able to identify all the key features of lines from a graph, right? Even if it didn't give you these points here, you should be able to identify the key values of these points. And the biggest problem, mistake people make from doing that is polling. They get them backwards, or they forget to add a negative sign to their respective ones. Remember, this is the x and this is the y, right? And x is left and right, that's the x, and that's the y. Okay, so this is positive x, this is negative x, this is positive y, this is negative y. Okay, so this is y, negative y, and this is negative x, if that helps everything, okay? So there you go. Let's move on through this. Okay, so first thing is first, whenever you're given any of this stuff, figure out the slope in whatever way you need to remember how to do it. Remember, the slope equals your change in y over your change in x. Easiest way to do this on a graph is recognizing one that is going downward. Since it's going downward, your slope is going to be negative, right? So you have a negative slope, and then look at the absolute value of the change. All right, you have a dot here on a nice coordinate plane intersection, and you have a dot here and a nice coordinate plane intersection. So this dot here and this dot here, your change in y, your delta, make yourself a nice right triangle right here and right here. Okay, it's a nice right triangle there. Your change in y is your red. Your change in y is 2 divided by your change in x, which is 3. Right, so your slope equals negative 2/3. Equals negative 2/3. And if you do the math, you'll see that your change in y is 3 minus 1, which is 2. And then your change in x is negative 3 minus 0, which is negative 3. So 2 minus negative 3 is negative 2/3. So there's our math for our slope, which is negative 2/3. Now we can ask for an equation. Now you could use your point slope form if you'd like, but we have the y-intercept right here, right? 0, 1, 0, 1, and we know the equation for slope-intercept form is y equals mx plus b, where this is your slope and this is your y-intercept. Okay, so might as well just use that to say that y equals negative 2/3 plus 1, because that is our y-intercept. So now we have an equation, because we know our y-intercept is plus 1, right? Or 0, 1 is also acceptable. Okay, so what's the x-intercept? Well, if it didn't show us what the x-intercept was right here, right, we could solve for it. Okay, we know it's 1.5, 0, right? But say we didn't know it, we could solve, we could solve for x here, okay? If we didn't know what the x-intercept was, we could solve for x, knowing the y-intercept, okay? So if we know that at the x-intercept, y is 0, right? So at the x-intercept, y is 0. So we would just simply put in 0 equals negative 2/3 x plus 1. And then we would solve for x, right? Negative 1 equals negative 2/3 x. Right, now we would multiply both sides by 3. So we have negative 3 equals negative 2x. Divide both sides by negative 2. X equals 1.5, or 3/2. So there you go. Checks with the math. All right, so what is the domain? The domain, let's put it in set builder form. Okay, the domain is going to be our purple section here, right? The domain, let's box it out. The domain goes from here to here. From here to here. Our maximum and minimum inclusive, right? Our domain. The minimum input we can do is negative 3, and the maximum input we can do is our x values. So it's negative 3 to 5, right? Negative 3, right, and then x, and then 5 inclusively, right? And it's going to be all real numbers, including our rationals and irrationals, right? So we'll just say our domain equals our curly brackets x. So our domain equals our x is our set of all real numbers, and then we start with our negative 3, which is x is greater than or equal to negative 3, but less than or equal to negative 5, and includes all real numbers. What's the wordage there? It is an element of all real numbers. And there you go. That is our so the domain is a set of x such that negative 3, such that x is greater than or equal to negative 3, but less than or equal to negative 5, and is an element of all, or correction, of 5, and is an element of all real numbers. There is our range. Okay. So now we got to do the domain. Oh, sorry, that is the domain. The range is the possible output for an input of our domain. Okay, so that's going to be any value of y that could get spit out from an input of our range, right? So it's our y values. Okay, so our minimum y value is negative 2.333. Okay, and then our maximum, and then we have our y's, and then our maximum is 3. So our range equals our set of all numbers y such that y is less than or equal to, correction, greater than or equal to all real numbers, or less than or equal to greater than or equal to negative 2.333, but less than 3, and is an element and is an element of all real numbers. And there you go. There's our domain and our range. Okay? So our domain is all of this, or our domain is all of this, our range is all of this. Hope that makes sense. All right, moving on to the next one.